Yeah, that is started. So has everybody opened this data? Sorry, opened R, not this data.
Yes, sir.
Yes, sir.
Okay. So as usual, do some ritual exercise. Check your working directory. So for checking working directory, the codes are get working directory. So open a chunk. Let me do along with you. So open a new file, then notebook, go on to the notebook. Okay, delete this part, insert a chunk, and then type get working directory. Okay. So, and run this chunk. Okay. So in my case, it is EP final folder. So I need to change this one. So if you want to change this one, then the command for changing working directory one is set working directory. And I think last time I created a folder on the desktop as name R. So let me check. Yeah, this one. So I'm going to make this R folder as my working directory. Similarly, you can do make your folder where as your working directory. So I'm copy path and then going to R and within code unable to paste. Okay, no issue. So I'm typing the path user Krishna, then desktop, then R and bracket close. So every time when we open or we can say start working with R, we can check our working directory and we make the folder as a working directory where we save all our data. So you can, now I can re-verify. So working directory has changed. So now it is R folder. Now as a next step, we import library, import packages. So few important packages that we generally import, or we can say with which we generally work. That one is the tidyverse. So the one is the tidyverse, and since you are going to use the data provided by the Woolrich, so data of LIBRARY. So I made a mistake in the top also. So I'm importing the Woolrich data. Sorry, I'm importing Woolrich library also. So these two library I called. Here is no package Woolrich. DRIDG, sorry, DRIDG. And oh, sorry, double D is here, it comes. Okay. It's a use. It's work now. Have you done?
So most of us don't have it pre-installed, so I might have to install it first. So please give us a moment. Yes.
So for installing the Woolrich package, I think last time you worked with the Woolrich package.
No, sir. Last time it was mostly ggplot and all those things. We didn't do Woolrich last time.
Okay.
It's the first time we are doing it today.
Okay. So you can install this package, install packages. So install packages, then under code, type Woolrich. So this, okay. And when we run this one, Woolrich package will be installed. Okay. We can also call one more library. That one is library open XLSX. So this one is for opening and when reading and writing Excel file. There are several other packages also which can read and write. So, but we will be using Open XLS package for reading and writing Excel file. Okay. Other one more package that I listed here. That one is, this one is for reading Excel again. So read Excel. Done?
Yes, sir.
What about the other?
One second, sir. 1 second. Done, sir.
Okay. Okay, so this time we are going to call a data which is named as wage one. So for that we type data. No, I'm thinking since that I'm missing something. Let me refer. So this one is for okay. So take a help from the R. Type here. Okay. Woolrich. So I need to call a data from the Woolrich. Okay. So that's why I'm opening this package. And then go down on wage 1. So this data I need. So it simply say data wage on 1. Okay. Okay, so use this one, data wage 1 is coming or not. So data wage 1. Yes, it has come. So yes. Yeah. So data undercode wage 1. Okay. So I call this data wage 1, and you can see here in the environmental window, data is listed, and when you click onto that, we can view the data. Okay. If you want to check the name of the variable or list the name of the variable, then for that, the command is names and then wage 1. So these are the variables names. So 1, 9, and 17 are the sequence. So the first column one is the wage, second one is the education, third one is the experience, and so on. Ninth one is SMSA. And as I told you, if you want to know more about these variables, then the detail of the variable are listed here. Okay. In the bottom right panel. So a wage is here the average of hourly earning, education is year of education, experience is years of potential experience, tenure is year with current employer, so on. Now let's make two-way table. So for making a two-way table, we can use table function. And under bracket, first we type the data file name, and then after putting this $sign, we call variable. So let's suppose that I'm calling a variable, which one is married, listed here. And then another variable, I'm calling that one is female. So table command we can use for making a table. So this one is the frequency table. Married and female are both qualitative variable, and coded here 0 to 1. So female, I think, okay, it seems like I didn't discuss it about the dummy variable. Okay, so qualitative variable we code, and we assign numerical value to the qualitative variable. So whenever there are two categories of the qualitative variable, we assigned one to value 1 and other to value 0. So if I say this, like gender has two categories, mainly two categories, female and male. So since gender has a two categories, so we create two dummies. One is the female dummy, one is the male dummy. So all the, you can say the persons, or you can say all the individual who are female, we assign 1 to them and 0 to others. So in that, so that one is in case of female dummy. For male dummy, we assign 1 value to male and 0 to others. So here you are considering a male value, a male dummy variable, sorry, female dummy variable. So female is taking a value 1 and male is taking a value 0. Similarly for married, so marriage is taking a value 1 and unmarried taking a value 0. So as per that, we can get this frequency table. So 0, 0 means male unmarried. Okay. So 0, 0 means male unmarried, because female is 1 and married is 1. Similarly, 1 is, which one is the 31, 32 value that we can read. So that one is the married female person. So have you any doubt regarding it? Can you hear me?
Yes, sir. No doubt so far. If anybody else has, please ask your doubt.
Anyway, let's then move further. So this one is for two-way table. Okay, we can also add sum to this table. And for adding sum to this table, what we can use? First, we assign an object to this table. So I am assigning object table 1. So after assigning, if I run this chunk, we do not get any output below to that. Output is listed in an environment window. So if I need to add sum total to the table 1, so in that case, I use this add margin command. So add margins and then table 1. So that's much. Let's say ADDMARGINS table 1. It's saying error in fun, invalid type of character. Let's view table 1. Oh. So look here, so TABLE, I missed when I was assigning the object name, I misspelled. Oh, sorry. So table 1, and now I'm adding this one. Now you can see here the sum. Okay, so this way we can add the margin. So add margin give you the sum total. How do you work with the table last time? You remember?
No, we didn't do tables last time, so this is the first time.
Yeah, okay. So now you are going to calculate the column and row percentage. So this one is for getting the total, sum total, some row total and column total, you can see. For calculating the column percentage, what we do, we type round and then 100 multiplied by proportion table. And then I use table 1, 2, and 2. So table 1 is my table that we had just created. 2 is for getting the column percentage, and 2 is here. Again, I want to get the figure in 2 decimals. So that's why I have written here 2. So if I enter this one, so look here, now we are getting the figure in a percentage term. Okay, if you replace this one with the 1, then it gives you in a 1 decimal. So 3 decimal case, if you go with this one come into a 3 decimal. For row percentage also, we just need to replace this 2 with the 1, and that give you the row percentage. So I think row percentage, I think the top one is for the row percentage and the below one is for column percent. So because 31 plus 47 become No. Sorry. And I was top one is for column percentage because 61 and 31 it's coming out here 100, 31.387 and 68.613. So first, the top one is the column percentage and bottom one is the row percentage. So for row, the option is 1 and for column, the option is 2. Let me know when you're done.
Done, sir. Done.
Okay, then let's move further. Now we are going to write this table into a Excel form. So for that, we use this write XLS function. So look here, it's coming in the bottom. So write XLS, and then we write the data file name. So we are going to write table 1. So we write here table 1. And then the file name that we want to give to this table. So I'm going to keep it as a table 1. Okay, table 1 Excel SX. And then you can use this override function. So make it true. So write.xls is the function name, then data file name that you want to write, and then again the file name that you want to name to your file, and overwrite equal to T. So when we enter and check your working directory folder, then you see there one file, Excel file name as table1 XLX. You can open that one so that you can do directly from the bottom left panel. So go on to the file, locate your directory, and then you can view the files. So now let's see, in my case, this one is the table. In a similar way, you can also write the data file. So since we had one data file that we imported, that we have taken from the old data file, but we can write it in an Excel file and then import it onto the Stata environment. So write XLS. If I name this one is wage one, and then wage one dot XLS over IT and enter. See here, a new file has created, which one is wage one XLS. And you can check the file. So this one is my data file. Now let's suppose in case if I delete all the data files from the environment window. Okay, so now I have deleted. I want to import the wage one data again, but not from the oldest library, but from the XLS, but from the directory file. So I can go on to, in that case, I import wage one data. So the procedure for that, I go on to the file, then import data set. And here you can see different options. So click onto the from Excel, browse your data, wage one. Okay, now you can preview the data and then import. Okay, so it has imported. The command are listed in the console window so that you can copy and paste. So read Excel file we have used and are by default has used for importing the data. And this one is the actual command that has worked for importing the data. So name this one is wage one. So wage one, read Excel, wage one Excel data. So has everybody done? Okay, let me know when you're done.
Can we go ahead?
Yes.
Okay. So moving further, now we are going to label our value. So when I say label, so remember if you open your data set, and we have seen this one earlier also, the non-white and female, or you can say the all character variable are coded here, coded with a different numeric value. So like in case of gender, so here you are having a female dummy variable, and those are that dummy variable is coded as 0 and 1s, the same as the married, the same as non-white here. So so what we do, we can also label our variables value. So I'm going to give one example where I'm going to label female variable values. So for that, the codes are these. So call your data set first, wage 1, then put a $sign, and then variable name female. So this would be our object name, because you want to make changes in our data file. So that's why I call the data file first and then variable name. And then I'm using the factor. So I'm letting this data know if the female variable is a factor variable. So not stata R, sorry for this misspelled. So wage 1, then $sign, then female again, I call the variable, and then I'm labeling labels equal to, then I'm putting C column value, I'm calling 1, 0, and then I'm assigning the labels name. So the labels equal to C, the first, since 1 and female is taking a value 1, so I'm writing here, naming that as female, and 0 for male. So this way we can label the value of the variable. I generally require labeling value of the qualitative variable, so that we can identify those values. So of course, then I generally do not prefer to label, okay, because it takes time. So here I'm labeling only one variable, or in the data set you can see there are many variables. Sometimes we do not work with all the qualitative variable, we work with the selected variable. So if required to label, so of course you can label. Otherwise, it's better to work with the quantitative value, okay. And when we bring your data set onto the Excel, at that time you can label the value of the variable instead of going from here. Okay, but it's all depend upon the convenience. Okay, so if one is convenient of labeling the value here, one must can do. Okay, I generally do not do, but this way we can label the variable. So if I run this chunk and go on to my data again, now you can see, probably I did a mistake. So sorry, let me check where is the mistake. So wage female factor, wage 1 female, label C female male. I can't see any mistake as of now, but can't say. So here I'm getting the female as NA. Earlier it was 0101. So let me check wage female, then factor, then wage 1 female, labels LAB, label C female. Okay. This one is lecture 2. Yeah, this command I'm using. Let's copy this one from here and paste. Yeah, look here, the below one is working. So in case of female variable, we can see here the value of female variable has labeled. Okay, and so and you can see here the 1 takes a value female and 0 takes a value male. Okay. Similarly, we can label the married also. So for married, the code written here. So if I copy this code and not here, I copy these codes and paste it into a new chunk. And enter, then again in the wage we can see here, if married is married has also labeled. So this was the incorrect chunk. Unable to check out the error, where was the error, but anyway, I'm deleting this one for saving my time. And so this way we can label. The importance of labeling value of the variable is that when we rerun this table, that means if when we generate this table again, like table, and add margin to that, now as a row and column variable, instead of having a value 0 and 1, we are having a value and we are having a non-numeric characters, okay, that are the married and unmarried. As the name, you label your variable. So one we can say the benefit of labeling, we get a nice table. Okay. So one can easily read this table in a more convenient way than the 0 and 1, because in 0 and 1 case, first we need to identify what 0 represent, what 1 represent, but here it is fully clear. Okay, because we have labeled 0 and 1 in both married and gender case. So this way we can label. Okay, let me know when we're done. Correlation, sorry, graph you have done last time, so I'm not doing that. Next week, calculate the correlation between variables.
Can we go ahead?
Yes.
Okay, so for correlation, the function name is cor. So this one is for getting a correlation. And of course, for correlation, you require two variables. So the core wage one, two quantitative variable. So I am calling education and wage one wage. So education and wage are two quantitative variable. So, so if you want to get the correlation between education and wage, so we'll get this from this command. Let's type double R. Yeah, double R is not working. So here it is.
So it is single R, COR.
COR, single R. Double R is in case of stata. I just checking. Okay, so this one is the correlation between two variables. You can also have the correlation between more than two variables. So in that case, we first need to bring your data in a data frame. I tell you later how would we bring a data in a data frame, and after then we just need to type this command. Like in this case, as per the and as of now, we are having only one data frame, which one is the wage one. If wage one, which contains several variables. So let's suppose that if I try to get the correlations of this data frame, wage one, and enter, it's not coming out. X must be numeric. Probably the first variable is non-numeric. So first you need to bring all the non-numeric variables as a one data frame, and then after when you type this command correlation under bracket that data file name, will get a correlation matrix. Here you are having a correlation value, but in that case you get a correlation matrix. So, okay. So moving further, now we are going to do we are going to assign an ID to our observations, and after assigning an ID, I split this wage data into two parts, and then we merge those two data files to one single file. So basically we are going to do the merging part. Merging part of R basics is can say, but we are going to do merging. So let me assign ID first, because ID is required for the merging. That's why we need to assign ID first to to this data set, because this data set doesn't have ID variable. So that you can check names. If you check with the wage 1, so we do not have any variable that we can use as a ID. Okay, so that's why I'm assigning an ID first, and to assign an ID, what I'm going to, I'm going to use the object name wage 1, and then wage 1, then this pipe operation, and then mutate function. So mutate function is for generating a variable. So I'm generating a variable ID, and I'm generating this variable. So ID equal to row number. So in case if I having a 500 row, like in our case, we are having a 526 observation. So in a sequence, we are going to generate, you are going to generate an ID which give a number in a sequence. So 1 to 526. So that's why I get written here row number and enter. Now you can see a changes in number of variable. Earlier we have 24 variable. Now we are having 25 variables, and we can also check this one by browsing your data. So as a last column, one variable has generated. So it has been generated. That's called the ID. So now we are having an ID variable. So remember the code that we have written. The first we assigned the object name because we want to make ID variable in our current data set, which one is the wage 1. Then I called the data. This is called a pipe operation. Percentage greater than percentage. So I use this pipe that mean here then. So data, first I call the data set, then what I want to do, I want to generate a ID variable. So mutate is the function for generating any new variable. So it's give you an additional variable. If you want to make a changes to the current variable, then in that case we have to type a transmutate. So this one is the mutate, and under bracket ID, and then I generated row number equal to this. So this one is, when I run this command, I get the ID. Sometimes what, okay, let's stop here. So this one. So I generated ID. Now I'm going to split my data set in, okay. After generating ID, generally, here we generated our ID in a very simple way, because our data set is not complex. So we just assign one unique value to each observations. But many times after generating ID variable is required to check whether you have generated ID successfully, or whether our ID variable uniquely identify each of the observations. So successfully, when I use this term, that means if your ID identify each observation uniquely, that means you have generated ID correctly. So to verify whether ID uniquely identify each observation, in this case, we write this code. So I type wage 1, and then again pipe operation, and then I count ID first. So I count ID, then I put this pipe operation, and then I type the filter. So filter, and then I say n is greater than 1. So here I am basically, first I am assigning first I am calling a data, then I am counting ID, and then I am saying, okay, report if ID number is greater, ID is greater than 1. The ID number, it's ID is not ID number exactly. It's when if there are more than one ID with a similar number. So that's I'm counting ID. And then, so I'm asking to report if n is greater than 1. So in this case, sorry, the COU and T, not D. So in this case, our report us 0 row. That means there is no duplicate observation or duplicate ID, you can say. Duplicate ID. So each ID here, sorry, each observation here uniquely identified by the ID variable. So that means we generated ID correctly. So that is required to do. But when you work with the NSSO data particularly, so for generating a unique ID in case of NSSO, we use several variables, okay? And at that time, there's a greater chances for making a mistake in generating ID. So when you make a mistake in generating ID, of course, your ID variable doesn't identify each observation uniquely. So that after generating ID, you require to check whether you generated ID successfully or not. That's why we do this task. So the mutate is a function for generating a new variable. Count is for counting, basically counting the number, and filter is for just filtering the particular value. So, like, I don't know how many you have exposed with the NSSO data, but with the case of NSSO, okay, there are 4 or 5 variables. So if I remember, one is the first stage unit, Hamlet group, second stage is Tatum, HSN for generating SHSN is household number. So FSU, first stage unit, Hamlet group, second stage is Tatum, household number for generating ID at a household level. For personal level, you can add personal serial number also. Anyway, when we work with the NSSO, we get encounter with all these things. Now, I'm going to split this wage data into 2 parts. So for splitting, I'm going to insert a chunk, and within chunk, I'm assigning a new data file name wage1_1. And then after I called wage1 variable, wage1 data first, and then I put this chunk, the wage1, then pipe operation, and then I select variable. So select, I'm going to select here wage, experience, and then ID, of course. But, and if I run this chunk, you can see a new data frame has generated, which one is wage 111. Okay, with a 3 variable. Okay. Correlation matrix work in this now. So the correlation, if I type here wage 1_1, so I get a correlation matrix. Look here, now you are having a matrix. Okay, so the earlier what I was telling, when you have a data frame, then we get a correlation matrix. When we get a correlation between variable, we get just a value. Let me know when we're done. Proceed further.
So please give us 2 minutes. But so this still gives us the correlation between only 2 variables, right? Wage and experience.
Wage and experience, but now you are having in a matrix form.
Acha, okay, thanks.
ID variable is also here. Na? Though ID is not a variable, sorry, it is a variable that not a relevant variable for this correlation
Hmm.
case.
Hmm. So what does ID signify? I'm not too clear on that.
ID is the identity number, you can say.
All right. Okay. Should we proceed?
Yes, Aishwarya.
Okay, so one data set we prepared, that one is the wage underscore one. And now we are going to prepare another data set. So let's name that wage one underscore two. And this time again, call wage one data first. The procedure remains same. And then select again. And this time you put a minus sign. And then we type wage experience, column experience. And then enter. Sorry, and then you run this chunk. A new data has been generated, which has 22 variables. Okay. So again, we are using a select function here, but under bracket stuffs are different from the earlier one. The earlier one, we are selecting 3 variables, wage, experience, and ID, and for a new data frame. Now we have started with the minus, and then under bracket I have put wage column experience. So that means we are going to consider all the variable except wage and experience. So when we open your data set, the original data set, wage one, then this data set start with the wage, education, experience, and so on. Okay. So wage, education, and experience, and the new data set that we have created, which start with the tenure non-white. That what variable are missing here? So 3 variable we missed from here. That one is the wage, education, and experience. So we education we also missed out. Okay. So that means when we put a column here, so wage column experience, that means all the variables which lie in between wage and experience, okay, along with the wage and experience will not be going to be part of new data frame. So that's why a new data frame we are having only 22 variable excluding wage, experience, wage, education, and experience, 3 variable, and in the first data set we are having a 3 variable. So later, now you can add. Okay, so we have prepared the 2 data set. Now I'm going to merge. So for merging, I'm typing another. So I'm assigning an object, which one is the wage 1 underscore 3. And I'm going to use a left join function. Or in the left join function, after left join function within bracket, I call the first data set first, splitted data set, and then the second data set, wage underscore 2, and then I merge by ID variable that we have generated. So by ID. So ID is a common variable which are in both of the data file. So we are using that common variable for merging the data set. So every time when we merge the data, okay, we always require a common variables, okay, and that common variable must identify each observation uniquely in both of the data set. If that is not hold, then we can't do merging. So left join is a function. So there are 3 functions, 4 functions, 4 or not, 5 functions in R that we can use for merging: left join, right join, inner join, full join. sorry, 4 function: left join, right join, full join, inner join. 4 function. So more about the left join, right join, you can read from the reference book that I suggested to read. R4 Data Science. That one very nice book. And when we go through that book and practice with that, after some time, you do not require any help. Okay, for working with the R. So now we can, when I run this chunk, a new data has been generated, and look, see it has 24 variables. Okay. So one is missing, that one is the education. So education somehow we dropped from the both of the data set. That's why you are having a 24, otherwise you have 25 variable. So now you can see all the variable are here, excluding education. So this way we can merge. We can also merge with right join. So since here if I type here right join, and then again this would be a wage underscore 4. So again we get the same number. So right join, left join doesn't matter when you have and when we have a ID variable which identify each observation uniquely, and also when you have the same number of observation in both of your data set. So this one is the one of the simplest merging case. Of course, merging is not simple as it seems like, or and merging is always difficult, and it becomes more difficult when we work with the complex data set. So for merging, always remember identifying key variable is required first. So here you are having only one key variable, that one is the ID. In many of the data set, we require to have a many key variables for demerging. So first we need to identify those key variables, and only then we can go and we proceed with the merging. Again, I am saying about the left join, right join, inner join, full join. You can read from the R4 Data Science. We can apply one in a very specific case. So the cases are given when we do a left join, when we do a right join, when we do an inner join, when we do a full join. Okay. Okay, when we have done, let me know. Proceed further. So in further we'll do the, okay, so further, so next we do the mean calculation. And after having a mean calculation, we run a regression. First the simple linear regression and then the multiple linear regression.
So I think we can move ahead.
Okay, then so you are going to do a mean calculation first. So for mean calculation, let's suppose that I want to get the mean of wage, okay, across married, female, and non-white variable. So for that, first I of course prepare assign an object name, so mean wage, and then I call the data then put this pipe operation. And then I group the data. So group by, the function name is group by. And I want to, as I said, told you, I want to calculate the mean of wage variable across gender, across marriage variable, and across race variable. So the for marriage, the variable that we have in the data set is married. For gender, you are having a female, and for race, you are having a non-white. So I want to get a mean variable across all these variables. So I'm going to group these variables. So I'm grouping these, this variable as married, female, and non-white. And then I am putting this pipe operation. Because more about the group, you can read in the R4 data science book. So after grouping, I use the summarize command, and in summarize, I calling a mean of wage. Okay, so me calculating the mean of wage. So summarize mean of wage, and when I enter, I get the output mean wage, and when I select, look here, I got the data. Okay. So non-white has not labeled it, so that's why it is at 0. So 0 is for the white people, and for non-white it is 1. So here you can read the data. A white married female average earning is 4.54. Probably it is a dollar per hour. And for married male, white person is 8.05. So of course, married male, white person is earning almost twice than the married female white person. So probably you all know about the gender wage differential. Okay, that's hold in India, and that's hold everywhere in the world. So that we can see here also. So this we get the mean, okay, across several groups. You put the one more option here, descending, then you get the figures in a descending order, descending, ascending, whatever way we can. Okay, sorry, summarize, not here. So let's copy this one and paste here. So after calculating the mean, we can arrange the value in a ascending and descending order. Descending, let's suppose that if I am want to descending order, then I say mean underscore wage. I mean underscore wage. Okay. I just summarize here. I need to give a name of this also, the mean summarize. Okay, I assigned object name. Okay. Mean wage, descending, mean wage. Okay. Arrange descending. Mean wage. So okay, I need to assign a name here first. Just whether this work or not. Mean wage equal to mean wage. Yeah. If I do this one, and then I go on to this one summary. Now you can see here in a descending order. Okay. So one thing you always remember, you can learn when we practice. Okay. Without practice, course, it is very hard to learn R or any software, not only R. R is initially difficult to learn. So trajectory path of R is flat in the beginning, unlike the other softwares. But it becomes steep after a certain point of time. Is everybody doing?
Yes, sir.
Okay, let me know when we're done. After this, we move to regression.
Everyone, can we start?
Yes, Maria. Yes, sir.
Okay. Yes, sir. Please.
For regression, so let's suppose that if I assign the object name regression 1, okay, so for regression, the function is lm. Data you are already have in our hand, so don't need to bring the data. So lm is the function for linear regression. So lm is linear model here. Then I type any variable. Let's suppose that wage, and then so wage is the dependent variable, and then all independent variable. So let's suppose that if you start with the bivariate regression model, so education become a independent variable here, and data that I am going to use, that one is wage 1. So this one is the single line command for the getting the regression result. So when I run this one, got the result, and for getting us summary regression 1 or getting the output of regression 1, I type summary regression 1. So this one is the output. So how many of here are from non-economics background? Amita, are you from economics?
Yes.
What about the others?
I'm not from economics, sir.
Ajay is also not from economics. Who are you here? I can't see the party. Ravi also not. Ujala, Ujala is from economics.
Yes, sir. I am from economics department.
Okay, so only Ujala and Amita are here from economics. Rest are not. Of course, for those who haven't studied econometrics at their undergraduate level or at a master level, they generally find difficulty for getting out of this regression result. And it is very hard to understand initially. Okay, but let me explain you about the meaning of all these and all these outputs. Okay, so, okay, so when we start with these coefficients, okay, so coefficient 1, this result I'm talking about, which I selected now. But for that, I have to write a regression equation. Okay. Okay, in this case, regression equation is yi equal to, you can say beta 1 plus beta 2 xi. So y is the dependent variable and x is the independent variable. yi equal to beta 1 plus beta 2 xi plus ui. So ui is the error term. So of course, when we proceed with this regression equation, you need to know what is this is ui, what is the relevance of ui. X and y are the two variables of which one is the dependent variable, other is the independent variable. Okay, and beta that I am talking about are the coefficient value. So beta 1 is here the intercept, and beta 2 is here coefficient value of education. So that is coming out 0.054136. So this one is beta 2 and this one is the beta 1. So many times beta 1 value is non-interpretable. So we ignore interpreting the beta 1, but we must interpret the beta 2. So this one is the beta 2. And this value derived out of using ordinary least square method. So that we call the OLS. So there is a detailed procedure for getting out this value using OLS software. The software give us in a second. These are the standard error associated with the coefficient value, and then the t value, then the p value. Okay. So t and p value we are used for knowing whether got-in coefficient value is statistically significant or not. So, and our objective is to get a statistical significant coefficient value. And as area for you, just like to say here, whenever p value is less than 0.05, that one is the conventional number that we can take. So less than 0.05, we can say that coefficient value is statistically significant. As in this case, coefficient value is statistically significant. Of course, I'm not going to interpret the standard error and t value because many of you do not understand all these things. Because for getting out the meaning of all these things, we have to start regression from the scratch. So, and of course, explaining all those things without having a blackboard or without having a sufficient time not possible. Because econometrics, basic econometrics is a semester, and we can teach in a semester. This is so of course it's very hard to teach even in a 1, 2, or 3, 4 lecture. But anyway, I was saying that a coefficient value is statistically significant when we get probability value PR that is under bracket greater than absolute 2, that we call p value really less than 0.05. So here that is statistically significant. Star here it means 3 star is you can see here again the 0 significance codes are given. Again the 0, there are 3 star. Against 0.001 is 2 star, 0.01 is 1 star, and so on. So 0.001, if you convert that into a percentage, it's coming out 1. 0 is basically even less than 1. So, but we can see here the coefficient value is statistically significant at 1% level of significant. If there are 2 star, then you can say coefficient value is significant at 0.01% level. If there is a 2 sorry to miss it, and 3 star is for 0, 2 star is for 0.001. So when we convert this one into the 100, it comes 0.1, and 1 star is for 1%. So 3 star, and whenever you are having a 1 star, that means 1%. And coefficient value is significant at 1% level of significance. So it is only in the Stata case you are getting so much of star. Our Stata and other software give a lesser number of stars. So I remember Stata. So 3 star in Stata case 1%, 2 star 5%, 1 star 10%. So so anyway, but when we interpret, of course, we can't say that 1%, 0% level of significance. It is very odd to say 0%. Of course, we can use 1%, even though we get p-value around 0. So p-value is here, education variable is almost 0. So, but you can interpret when we interpret in terms of significance, and a convention is that in practice you can use 1%. So here you can say coefficient value of education variable is significant at 1% level of significance. Okay. After interpreting the coefficient value, we can interpret the R square. So the R square is 0.1616. So here you can say the 60% of variation in Y explained by X variable. So X is education. So any more a significant interpretation would be the, or the appropriate interpretation would be the 60% of wage variable, variation in wage variable explained by the education alone in this case. F statistics, it's talked about the overall fit of the model. So again, we have to check with the p-value of F statistics. And whenever it is 0.05, we say that model is fitted good. In the top, there are residuals. So it's a distribution of the residuals. So you can get an idea about the distribution and heteroscedasticity or homoscedasticity, you can say. Okay, whether regression model satisfy assumption of homoscedasticity or not. So OLS basically builds on several assumptions. So after running this regression, it required to check those assumptions, whether OLS satisfies those assumptions or not. If not, then we can use appropriate measure for get rid of the problem so that OLS model satisfy all the assumptions of classical linear regression model. So that are the case. Of course, as I told you, it's not very, it's very hard to explain everything without Blackboard and with. So skipping that, if I move on to the multiple linear, so this one is for the simple linear. For a multiple linear, again, we can use the same code and add one more variable. So let's suppose that I'm going to add experience variable also. So experience, I'm adding experience also along with the education. And if I run, and then I run this one, then take a summary. So summary of regression. Sorry. Regression 2. So now you can see here the one more coefficient value has added, that one is the experience, and it is statistical significant again. So of course, that's a partial interpretation of both education and experience. When I say that, just say that coefficient value is statistically significant. So when we interpret, basically we consider three aspects, or we interpret the coefficient value in considering all these three aspects. So at the first stage of interpretation, we can look whether coefficient value has taken an expected sign or not. So generally, in this case, we expect a positive relationship between education and experience with wage earning. So we expect that both of these positively affect wage earning. So that's why, and the same is confirmed here. We are getting a positive value. So after getting satisfying the first criteria, you can say, or first aspect, not criteria, regression model, coefficient value have taken an expected sign. We move on to the talking about the changes in wage due to changes in education. then the changes in experience. So in case of education, it has taken expected sign. And when we interpret, we interpret average changes in Y due to changes in X. So here you can say when education increased by 1 more year, on average, earning of individual goes up by $0.64. So assuming that Y is measured in a dollar, so $6.6 per hour if the wage is in per hour. And then we talk about the significance. Then we can say that the education coefficient value is statistically significant. So in this 3 way, we can interpret the coefficient, not 3 way, all these, considering all these 3 aspects, we can interpret the coefficient value. Of course, more about you get in any book, so any econometrics book. So we can do that. I also recommend one book of econometrics using R. So when I share this lecture note 2 notebook file with you, in the last I mention here the reference reading also. In this lecture note 2, apart from the regression results, I have also calculated the Y hat, U hat 1, mu hat 1. So once you go through that book, you find all these things. Okay, so at that time you can practice with it and try to understand what it all about. Of course,
Sure, sir.
If you go through that book, then you able to get out everything. So I think this code when I was running was not working. So I'm deleting this one. Anyway, this one. Okay, so that's much for today. If you have any doubt, then you let me know. No doubt.
No, none so far, sir. If anybody else has got a doubt, please feel free to ask.
I especially advise Ajay and Robbie to learn R for working with big data set.
No, sir, no doubt.
But one thing I realized by building CBGA is the thing that we can do with Excel, and in that case we can like you can select one state, work with that, then you select another state, work and similar kind of work we repeat with the other district file or even the state file. So I'm telling you, with this software we can do and you can work with all the state file or district file simultaneously. Okay, so with the one command work for all the district, all the states. So of course, when we combine all the district data or all the state data, number of observations goes up. Like in PM Kisan case, when I combine 55 districts data, then in that case observations going around 1.64 lakhs. Yeah. And of course, none of our computer, okay, what and it deals with that large number of observations, because because I tried that one, I write that number of observation in Excel, so first Excel is not opening. Okay, and when I brought that data on R on my desktop, then R start crashing. Okay, because my computer we're getting a sort of memory. So of course, the solution of that is I'm working with the cloud computing. Okay, so and there I opened R and working with that. Let me stop recording. Yeah, so that I can see your name. So I'm just giving you a